Here we have one special question to understand equation of line and its special cases. Specifically, we will understand the different situation like if line is parallel to x-axis or y-axis or it is passing from origin, then what will happen with the equation of line. So let's try to solve it. In this question, we have to find value of k for which the equation of line k minus 3x minus 4 minus k square y plus k square minus 7k plus 6 is equal to 0 is parallel to x-axis or parallel to y-axis or passing through origin. Let's say here we have our x and y axis. Now let's case your first case where your line is parallel to x-axis. Now we know that for any line which is parallel to x-axis can be represented by y is equal to constant, or we can say y minus b equal to 0. So as you can see, the coefficient of x must be 0. So in our equation of line, the coefficient of x is given by k minus 3, which must be 0. So you'll get k is equal to 3 for your first case. Now let's move to the second case where line is parallel to y-axis. Now any line which is parallel to y-axis can be represented by x minus a equal to 0. So as you can see, in this case coefficient of y must be 0. So in our equation of line, coefficient of y is given by minus 4 minus k square. It must be 0. So we can say, we can ignore this minus and we'll get k minus 4 and k plus 4 is equal to 0, which will give us two values of k plus or minus 4 for second case. Now for the third case in which your line is passing through origin, we can say its constant term must be 0. So in our case, the constant term is k square minus 7k plus 6 must be 0. So we have to create the factors. So we'll get k minus 6 and k minus 1. So for this case, we'll get two values of k, 6 and 1. So we can say we get the values of k for all the cases. So in this question, you learn that if line is parallel to x-axis, we can say coefficient of x must be 0. And if line is parallel to y-axis, then coefficient of y must be 0. And if it is passing from origin, so its constant term is 0. So you have to remember this information. Ta-da! Here we have one interesting question. We have to find perpendicular distance from origin to the line joining points cos theta sin theta and cos phi sin phi. Now we have to find perpendicular distance from the origin, and for that we need equation of this line L. Now here we have 2 points, let's say x1 y1 and x2 y2. So we can say we can use 2-point form of equation of line. So we'll get y minus y1, which is sin theta. So first of all place the value of y1, then y2, which is sin phi, is equal to x minus x1, which is cos theta. Then we'll place the value of x2, which is cos phi. Now to simplify this, we have to interchange these two terms, something like this. Now we get all the constant term on the right side and unknown term on the left side, so we can further simplify. Now if we talk about numerator, we have s minus s, which can be simplified as 2cs, where in first trigonometric term we have to take summation of the angle by 2, and in second trigonometric term we have to take difference of the angle by 2. Now in numerator we have c minus c, which can be simplified as minus 2ss. So here we'll get minus 2 sine and sine, and we know that in first term we'll get 5 plus theta by 2, and in second term we'll get 5 minus theta by 2. So as you can see, your term of sine and 2 will be cancelled out. We will get y minus sine theta upon x minus cos theta is equal to cos upon sine 5 plus theta by 2. Now for further simplification, we have to cross multiply this minus sine 5 plus theta by 2 multiply with y minus sine theta. So we'll get minus sine 5 plus theta by 2 into y, and minus minus become plus sine 5 plus theta by 2 into sine theta is equal to cross multiply cos 5 plus theta by 2 into x minus cos 5 plus theta by 2 cos theta. Now let's collect all the terms of the right side. So the terms of right side will be as it is. And now let's move down of the left side on the right side. So this will become plus sine 5 plus theta by 2 into y, and this term will become minus. So we can say from constant terms we can take minus common, so this will become plus. So here we have cos alpha cos beta plus sin alpha sin beta form, which can be simplified as cos alpha minus beta. So here we get cos alpha, which is 5 plus theta by 2 minus your beta, which is theta, and rest of the terms will be as it is. So we can say we get our equation of line L, which is cos 5 plus theta by 2 into x plus sine 5 plus theta by 2 into y minus cos, if we take LCM of 2, you will get 5 minus theta by 2 is equal to 0. And the perpendicular distance from origin is given as mod the constant term of the equation of line upon under root of coefficient of x, which is cos 5 plus theta by 2 whole square, plus coefficient of y, which is sine 5 plus theta by 2 whole square. So we'll get P is equal to mod cos 5 minus theta by 2, and your denominator will be 1. So tada! We get our perpendicular distance. Here we have another question depending on intercept form. You have to find equation of line which cut off intercept on axis whose sum and product are 1 and minus 6 respectively. So we have to use intercept form of equation of line, which is x by a plus y by b is equal to 1, where a and b are x and y intercept, and we have to find them. And for that we have two conditions. First one, sum of intercepts are 1. So we can say a plus b must be 1, or we can say your b must be 1 minus a. Let's say this is your first equation. Now to obtain second condition, it is given that product of intercepts are minus 6. So we can say a into b must be minus 6. So we get our second equation. Now we have to solve this equation, and for that we use elimination method. Let's substitute value of p from first equation. Now let's open the bracket. A ones are A minus A into minus A will be A square is equal to minus 6. Or collect the term on the right side will give us quadratic equation of A square minus A minus 6 is equal to 0. Now to factor this we need two digits having product is equal to constant term which is minus 6 and summation is equal to coefficient of middle term which is minus 1. So we can say our required two numbers are 2 and minus 3. So your first and last term will be as it is. We will split your middle term into minus 3a and plus 2a. So from first two terms we can take a common, so we get a minus 3, and from last two terms we can take 2 common, so we get a minus 3 again. So here we'll get a minus 3 and a plus 2 as a factors. So here we get two options. First one a equal to 3 and second one a equal to minus 2. Now we need to get your second unknown which is b. From first equation we can say for first case b must be 1 minus a which is 3 will give us b equal to minus 2. So we are ready to obtain equation of line x by a which is 3 and y by b which is minus 2 is equal to 1, or we can say 2x minus 3y is equal to minus 6 is your first equation of line. Now in second case where a is equal to minus 2 we will get b is equal to 1 minus a which is minus 2, or we can say b will be 3, and the equation of line will be x upon a, or we can say minus 2, and y upon b which is 3. So here we get 3x minus 2y is equal to minus 6. So here we get two required equation of line which satisfied our condition. Tada! Now we have same type of another question. Actually 90% question is same. We have to find point on y-axis. So we can say this time we should assume 0, b as your point whose perpendicular distance from line x by 3 plus y by 4 is equal to 1 is 4 unit. So as you can see both questions are same, only difference of assumption of point. So let's follow the same steps. We will get standard form of line as 4x plus 3y minus 12 equal to 0, and now we are ready to apply the formula. In numerator you have to place equation of line, and in denominator under root of coefficient of x square plus coefficient of y square. Now substitute x coordinate of a point instead of x and y coordinate of a point instead of y. It is given that your p is 4, so we'll get mod 3b minus 12 upon 5, which will give us mod 3b minus 12 is equal to 20. Now when we remove the mod we'll get two options. In first option we'll get plus 20 and in second option we'll get minus 20. So from 3b minus 12 equal to 20 we'll get 3b is equal to 20 plus 12, or we can say 32, or we can say this time we'll get b is equal to 32 by 3. Similarly in second case you have to take minus 20 plus 12, or we can say minus 8 will give us b is equal to minus 8 by 3. So your required point q is nothing but 0, 32 by 3 or 0, minus 8 by 3. Tada! I hope you understand the formula, and now you can apply the formula for and its application. In this question, you have to find area of triangle formed by three lines. First one, y minus x equal to 0. Second one, x plus y equal to 0. And third one, x minus k equal to 0. And for that, we have to find their vertices. Let's say point A is intersection of line L1 and L3. So we have to solve these two equations. Let's make x objective, we'll get k, and substitute in above equation, we'll get y minus k is equal to 0, or we can say you will get y is equal to also k. So here we get the coordinate of point A, which is k comma k. Similarly, we have to find second point B, which is nothing but intersection of line L1 and L2, and we have to solve this two equation. Let's rearrange the term of second equation. Let's say it is y plus x. So we can add these two equation. Your x will cancel out. We will get 2y equal to 0, or we can say y must be 0, which will give us x equal to 0. So we can say we get the coordinate of B as 0, 0. Now we have to go for the last intersecting point, point C, which is intersection of line L2 and line L3. So we have to solve these two equations, and for that let's take a difference. So here your x will cancel out, so we'll get y plus k equal to 0, or we can say y equal to minus k, and we already have x equal to k. So the coordinate of C will be k and minus k. So we get the coordinate of A, B and C. So we can say area of triangle ABC is given by half mod x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. If you have problem to deal with equation, let me show you one trick. First of all, select x coordinate of any random point. Here we are selecting k. We have to move in anti-clockwise direction, and we'll take difference of y coordinate. In this case, we have to take 0 minus k. Then same thing you have to do with the second point. We are selecting x coordinate and then move in clockwise direction and take difference between y coordinate. So we'll get minus k. And finally, we'll select third point having x coordinate k and move in clockwise direction. So we'll get k minus 0. So let's simplify. K into k will become k square, then 0 into anything will be 0, and again k into k will be k square. So here we'll get half mod 2k square, or we can say your area of triangle is simply k square, square units, as your final answer. Tada! In this questions, we will learn how to deal with the concurrent line. The concurrent lines are lines which are intersect at a single intersecting. So let's begin the question. In this question, you have to find value of P so that three lines may intersect at one point. So let's say your first line is L1, 3x plus y minus 2 equal to 0. Then the second line is L2, px plus 2y minus 3 equal to 0. And third line is L3, 2x minus y minus 3 equal to 0. So if they have common intersect, then intersecting point is on all of these three lines. So first of all, we'll try to solve equation of L1 line and L2 line. So let's get them one by one. Now, to solve this, we use elimination method. We just add these two equations. So 3x plus 2x will be 5x. Your plus or minus y will be cancelled out, and minus 2 minus 3 will be minus 5 is equal to 0. So here we'll get x is equal to 1. Now we can substitute in any one of the equation. So let's put in your first equation. So we have to replace your x by 1. So we'll get value of y is equal to minus 1. To find the value of p, we will use this intersecting point 1, minus 1, which is on line L2, which is px plus 2y minus 3 equal to 0. So it must satisfy the equation. So let's substitute the value of x, which is 1, and value of y, which is minus 1. So we can get p is equal to 5, which is your required answer. Ta-da! So you get the idea how we can deal with the three concurrent lines. First of all, we have to solve two equations using any method and then substitute the value of intersecting point on third line. So let's use same method in your next question. Here we have three lines and they are concurrent. So we have to prove this thing. So as you can see, we have same question. Let's see, your first line L1 is y minus m1x plus c1. Then the second line L2 is y is equal to m2x plus c2. And the third line L3 is m3x plus c3. Now we know the process. To deal with the concurrent line, we will solve any two equation. So here, to solve equation of first line and second line. So let's get them. And for that, we have to take difference between these two equations. So your y will cancel out. So you'll get 0. Then from these two terms, we can take x common. So we'll get m1 minus m2. And here we'll get c1 minus c2. Now let's make x subjective. So we can say x m1 minus m2 will be as it is, and we'll move the constant term on the right side. So it will become minus c1 minus c2. Now this m1 minus m2 will move to the denominator of the right hand side. So we will get x is equal to minus c1 minus c2 upon m1 minus m2. Now in next step, we have to substitute this value in any one of the equation. Let's place in your first equation of line. So we can get value of y. Your m1 will be as it is, and we get the value of x plus c1. Now let's simplify. Let's multiply minus m1 within the bracket. So we'll get minus m1 c1 plus m1 c2. Then we have to take LCM. Multiply m1 minus m2 with c1. So we'll get m1 c1 minus m2 c1 upon m1 minus m2. So as you can see, minus m1 c1 plus m1 c1 will cancel out. We will get y is equal to m1 c2 minus m2 c1 upon m1 minus m2 as your y coordinate. So as you can see, we get intersecting point having x coordinate as minus C1 minus C2 upon M1 minus M2, and y coordinate is M1 C2 minus M2 C1 upon M1 minus M2. Now we know the next step. We have to substitute in remaining third equation of line. So instead of y, we have to substitute the y coordinate. Then instead of x, we'll place your x coordinate. Now we just have to simplify. Let's take LCM of M1 minus M2, which should multiply with C3. So we can say we'll get M1 C2 minus M2 C1 is equal to minus M3 into C1 minus C2 plus C3 into M1 minus C3 into M2. Now, let's collect all the terms on the left side. First of all, collect the terms of M1. So you'll get M1 C2 minus M1 C3. Now, collect the terms of M2. So we'll get M2 C3 minus M2 C1, and then move this term on the right side. So it will become plus M3 into C1 minus C2 is equal to 0. Now, as you can see, from first two terms, we can take M1 common, we'll get C2 minus C3. Then from these two terms, we can take M2 common, so we'll get C3 minus C1. And your last term will be as it is. So here we prove that M1 into C1 minus C2, M2 into C3 minus C1 plus M3 into C1 minus C2 is equal to 0. Hence proved. Now let's talk about second method. In this method, you can use determinant, which is made from the coefficient of equations of line. For concurrent line, this determinant must be 0. Now let me show you how. The coefficients in first equation are 3, 1 and minus 2. Then in second row, we have to place P, 2 and minus 3. And third row will be 2, minus 1 and minus 3. Now it must be 0. Let's expand with respect to first row. So we'll write down the elements of first row with the proper sign. Now we just have to multiply with the cofactor. Now to fill first bracket, you have to ignore your first row and first column and then cross multiply. Minus 3 2s are minus 6 minus 1 into minus 3 will be 3. Now for next phase, you have to ignore first row and second column and then cross multiply. Minus 3 into P will be minus 3P minus 2 into minus 3 will be minus 6, and the last will be minus 1 P's are minus P minus 2 2's are 4. So here we get 3 into minus 9, or we can say minus 27, then plus 3P and minus 6 and plus 2P and plus 8 is equal to 0, or we can say 3P plus 2P will be 5P and minus 27 minus 6 and plus 8 will be minus 25, must be 0, which will give us P is equal to 5. So this is the easy way to get the value of P and deal with the concurrent line. You can use this method to solve the second example also. You just have to make determinant, but you should remember that for that your lines must be in the general form of equation of line. You should convert your first line L1 as a M1x minus y plus C1 is equal to 0. Similarly, the second line will be
m2x minus y plus c2 is equal to 0, and third line will be m3x minus y plus c3 is equal to 0. Now we can make the determinant using coefficients, and it must be 0. So let's expand here with respect to first column. So we have to place its elements with the sign of cofactors. So to find cofactor of m1, we have to ignore first row and first column and then cross multiply. We'll get minus c3 minus c2. Then to get the cofactor of m2, we have to ignore first column and second row and then cross multiply. We'll get minus c3 minus c1 and then ignore first column and last row and cross multiply. We'll get minus c2 minus c1. So if we rearrange the term, we'll get c2 minus c3, then multiply negative sign within the bracket c3 minus c1 and m3 into c1 minus c2 must be 0. Hence proved. Ta-da! So you can use this method for MCQs. Hope you enjoy and learn how to deal with the concurrent line. So solve this type of a question in your assignment. Till then, bye-bye.
In this question, you have to find equation of line which is passing from point P 3, 2 and making an angle of 45 degree with line L x minus 2y equal to 3. Now, let's try to see this question graphically. First of all, let's say this is your given line L x minus 2y minus 3 equal to 0. Now, we have to find a line which make an angle of 45 degree with line and passing from point P. Actually, we will get two lines which satisfy these conditions. So let's try to find them. To use angle, we need slopes. Let's say slope of line L is m, which is obtained from equation of line, or we can say from third case, which is minus a by b, where your a is coefficient of x upon b is coefficient of y. So you'll get 1 by 2. So you'll get m1 is equal to 1 by 2. Now let's assume that slope of our unknown line is m and it making an angle of 45 degree between L and N. So we can apply the formula of angle between two lines, which is m minus m1 upon 1 plus m into m1, where your angle is 45, your slope of second line is unknown, and we find out your m1 as 1 by 2. So you get 1 plus m into 1 by 2. Now, we know that your tan 45 is 1 and here we have to take LCM of 2. So you'll get 2m minus 1 by 2 upon, in numerator, we also have to take LCM of 2. So you'll get 2 plus m whole divided by 2. So we can cancel out this 2 and we get mod 1 is equal to 2m minus 1 upon 2 plus m. So if we remove the mod, we will get 2m minus 1 upon 2 plus m is equal to plus or minus 1. So let's take both case one by one. In first case, we'll take plus 1. So we'll get 2m minus 1 is equal to 2 plus m, or we can say 2m minus m will be m and 2 plus 1 will be 3. Similarly, in second case, we have to take minus 1 and cross multiply. So get 2m minus 1 is equal to minus 2 minus m, and 2m plus m will become 3m, and minus 2 plus 1 will be minus 1. Or we can say this 3 will move on the right side into the denominator. So here we get two lines. Your first line having slope is equal to 3 and passing from point 3, 2. So we can use slope and point method, which is m is equal to y minus y1 upon x minus x1, where your slope is 3 and y1 is 2 upon x minus x1 is 3. To get the final answer, you have to multiply x minus 3 with 3. So we'll get 3x minus 9 is equal to y minus 2. Or we can say 3x minus y minus 7 equal to 0 is required first line. Similarly, for second line, we have to take slope as minus 1 by 3 and point as 3, 2 and use the same formula. M is equal to y minus y1 upon x minus x1. But this time, your slope is minus 1 by 3. And on right hand side, we'll get y minus 3 upon x minus 2. Now, just cross multiply x minus 2 with minus 1 will give us minus x plus 2. And 3 with y minus 3 will give us 3y minus 9. Or we can say x plus 3y minus 11 equal to 0 is your required second equation of line. So, ta-da! This is your final answers. In this question, we have to show the equation of line passing through origin. That means your given point is 0, 0, and making an angle of theta with line y is equal to mx plus c is given by this equation. So we have to prove it. First of all, we will find out slope of this line, which is m. Now, your unknown line is, let's say, L1 having slope m dash is equal to x, and we have angle theta between line L and L1. So we can use the formula of angle between two lines, which is tan alpha is equal to mod m1 minus m2 upon 1 plus m1 into m2, where your m1 is unknown for us, which is x, and m2 is given data as m, and we know that your angle is also given as theta. So we'll get tan theta is equal to x minus m upon 1 plus x into m. Now, if we remove the mode, we have to write down plus or minus on the left hand side. Now, in further simplification, we have to multiply plus or minus tan theta with 1 plus xm, and your right hand side will be as it is. So, plus or minus tan theta ones are plus or minus tan theta, and multiply with the second term will give us plus or minus tan theta into xm is equal to x minus m. Now, we have to remember that what we have to find. In this question, we need to find out x. So let's make it subjective by collecting the terms of x on the right side. So we will get your x as it is, and this term on the right side will become minus plus, because it will change its sign. Now, rest of the terms will be collected on left hand side. So this plus or minus tan theta will be as it is, and your minus m will become plus m. So from right hand side we can take x common and we'll get 1 minus plus m tan theta, and your right hand side will be as it is. So we can say your x is equal to m plus or minus tan theta upon 1 minus plus m tan theta. So we can say we get slope of our unknown line, and it is already given that it is passing from point 0, 0. So we can use slope and point method, which is m1 is equal to y minus y1 upon x minus x1, where your slope is m plus or minus tan theta upon 1 minus plus m tan theta is equal to y minus y1, which is 0, upon x minus x1, which is again 0. So we can say we get our required equation of line as given. Hence proved. Ta-da! Now, if we don't substitute the value of y1 and x1, then we will get one shortcut which can be used to obtain line which is at the angle of theta and passing from x1, y1. In this question, we have to find equation of line which is perpendicular to given line x by 4 plus y by 6 equal to 1 through the point where it meets y-axis. Now let's say this is your given equation of line L, whose x-intercept is 4 and y-intercept is 6. Now, our required line is passing from this point where it meets y-axis and perpendicular to given line L1. So we can say it is passing from 0, 6. Now we'll use given equation of line x by 4 plus y by 6 is equal to 1. Or if we take LCM, we'll get 6x plus 4y is equal to 24. Or we can say minus 24 equal to 0 is the general equation of line. Now we know that our required line is perpendicular to our given line. So let's use general equation of perpendicular lines. And we know that we need coefficient of x, coefficient of y, and constant term. And for that, we just have to exchange coefficient of x and coefficient of y and change the middle sign. We have plus, so we have to place minus. And the only unknown will be constant term c. Now, to find c, we know that line is passing from the point 0, 6. So instead of x, we have to place 0. So you'll get 4 into 0 minus, instead of y, we'll place 6. So you'll get 6 into 6 plus c is equal to 0. Or we can say your c must be 36. We get the value of c. So we can say our required equation of line will be 4x minus 6y plus 36 equal to 0. Or if we take 2 common, we will get 2x minus 3y plus 12 is equal to 0. Ta-da! In this question, we have to find in what ratio the line joining point A minus 1, 1 and 5, 7 is divided by line x plus y is equal to 4. So, to find the ratio, we have to find out dividing point. Let's say its coordinate are AB. Now, we know that coordinate of dividing point of line AB in the ratio of, let's assume lambda is given by A is equal to lambda bracket plus 1 bracket upon lambda plus 1, and in first bracket we have to substitute x coordinate of the opposite edge, and in second bracket x coordinate of home point. So here we'll get 5 lambda minus 1 upon lambda plus 1 as your A. Similarly, to find B, we have to place lambda bracket plus 1 bracket upon lambda plus 1. So in first bracket we'll place 7 and 1. So we'll get 7 lambda plus 1 upon lambda plus 1. So we get point B. Now we know that point P is on line L having equation of x plus y is equal to 4. So it must satisfy its equation. So let's place the x coordinate instead of x. So we'll get A plus y coordinate instead of y. We'll get B is equal to 4. But we already find out value of A as well as value of B in terms of lambda. So now we just have to simplify. We have to take LCM of lambda plus 1. So let's multiply with 4. So your left hand side will be 5 lambda minus 1 plus 7 lambda plus 1 is equal to 4 lambda plus 4. In further simplification, let's collect the terms of lambda. So you'll get 8 lambda is equal to 4, or we can say the required ratio is 1:2 as your answer. Ta-da! Here we have one interesting question. It is given that if sum of perpendicular distance of variable point P from line L1 and L2 is always 10, then we have to prove that P must move on line. And for that, first of all, we have to find perpendicular distances. We know that we need point as well as line. So let's say our point is P having coordinate x, y, and we are finding perpendicular distance from line L1. X plus y minus 5 equal to 0. So P1 must be mode of equation of line upon under root of coefficient of x square plus coefficient of y square. And instead of first bracket, we have to place x coordinate, and in second bracket, we'll place y coordinate. So we'll get mode of x plus y minus 5 upon under root of 2. Similarly, we have to find perpendicular distance from P to the line L2, which is 3x minus 2y plus 7 is equal to 0. Let's say it is P2 and its numerator will be mode of equation of line upon under root of coefficient of x square plus coefficient of y square. Instead of cross bracket, x coordinate and y coordinate. So we'll get mode of 3x minus 2y plus 7 upon under root of 13. Now, if we recall the question, it is given that sum of perpendicular distance is always 10. So we can say P1 plus P2 must be 10. Now, let's get the value of P1 and the value of P2 must be equal to 10. Now let's take LCM. Root 13 multiply with this will give us root 13 mode x plus y minus 5 plus root 2 multiply with this will give us root 2 mode 3x minus 2y plus 7 is equal to 10. Here, you should remember that
when we remove the mode, we have to place plus or minus. So your second term will also become plus or minus root 2. Now, in further simplification, let's open the bracket. Plus or minus root 13 into x will give us plus or minus root 13x. Then plus or minus root 13y. And minus plus 5 root 13. Similarly, from second bracket, plus or minus 3 root 2x and minus plus 2 root 2y and plus or minus 7 root 2 is equal to 10. Now, from these two terms, we can take x common. So, we'll get plus or minus root 13 plus or minus 3 root 2. Similarly, let's take y common. So, we'll get plus or minus root 13 and minus plus 2 root 2. And the rest of the terms are constants. So, collect them is equal to 0. So, we get equation of trace of point P, which is in the form of ax plus by plus c equal to 0, which is equation of line. So, your variable point P must move on a straight line. Hence proved. Ta-da! Here we have one interesting question. We have to find equation of line which is equidistance from two parallel lines. Let's say L1 9x plus 6y minus 7 equal to 0, and second line is L2 3x plus 2y plus 6 equal to 0. Now we know that to apply the formula of perpendicular distance, the coefficient of x and coefficient of y must be same, which condition is not satisfied over here. So to satisfy our condition, we have to multiply whole equation by 3. So your equation will become 9x plus 6y plus 18 is equal to 0. Now, we have to find line which is parallel to these two lines. So, its general equation must be 9x plus 6y plus c is equal to 0, and which is equidistance from these two lines. So let's find out perpendicular distance between them and compare it. So first of all, let's try to find out perpendicular distance between line L1 and line L3, which we assume as D1. So your numerator is made from difference of constant terms. So it will be c minus minus 7, or we can say plus 7 upon under root of common coefficient of x square plus common coefficient of y square. Similarly, perpendicular distance between line L2 and line L3, which is denoted by D2. So in numerator, take a difference of constant terms. So we'll get c minus 18 upon under root of coefficient of x square plus coefficient of y square. Now, it is given that your line is equidistant from these two lines. So we can say your D1 must be equal to D2. So let's compare your D1 with your D2. So as you can see, your denominator will be cancelled out and we'll get mode of c plus 7 is equal to mode c minus 18. Now, we know that when we remove the mode, we have to place plus or minus. So here we get two different cases. First one, c plus 7 is equal to c minus 18, or c plus 7 is equal to minus of c minus 18. So in first case, your c will be cancelled out and you will get 7 is equal to minus 18, which is not possible. And in second case, you will get c plus 7 is equal to minus c plus 18, which will give us 2c is equal to 11, or we can say your c will be 11 by 2. So we can say your required equation of line L3, which we assume as 9x plus 6y plus c equal to 0, is actually 9x plus 6y plus 11 by 2 equal to 0 as your acceptable answer. Ta-da!
In this question, we have to find the direction in which straight line must be drawn passing through minus 1 comma 2. Let's say this is your A point. So that point of intersection with line x plus 4 may be at distance of 3 units from this point. Let's say here we have our point A, which is minus 1 comma 2, and this is your line L2 having equation x plus y minus 4 equal to 0, and we have to draw a line which is passing from A and its intersecting point, let's say Q, having coordinates A comma B, may be at distance of 3 units from point A. So we have to find the equation of line AQ. To find equation of line AQ, we need to find coordinates of Q. We have two coordinates, so we must find out two equations. Now, first of all, your point Q is on line L2, which is having equation x plus y minus 4 equal to 0. Q must be satisfied equation of L2 line. So if we place x coordinate of Q, we will get A plus y coordinate of Q, B minus 4 equal to 0. Or we can say we will get B is equal to 4 minus A. Let's say this is your equation number 1. Now, it is also given that distance between point A having coordinates minus 1 comma 2 and Q having coordinate A comma B is given by 3 unit. So let's square both the side. So AQ square is given by difference of x coordinate, which will give us A plus 1 the whole square, plus difference of y coordinate, which will be B minus 2 the whole square, is equal to 9. Now let's expand your A plus 1. We'll get A square plus 2A plus 1. And before we expand our second term, we should substitute the value of B, which is 4 minus A. So we'll get 4 minus A minus 2, or we can say here we have to expand 2 minus A. So we'll get A square minus 4A plus 4 is equal to 9. So here we'll get A square plus A square, or we can say 2A square. 2A minus 4A will be minus 2A. 1 plus 4 minus 9 will be minus 4 equal to 0. Or we can say we will get, or if we take 2 common, we will get A square minus A minus 2 is equal to 0, which can be factorized as A plus 1 and A minus 2 is equal to 0. So here we'll get the first one, A is equal to minus 1, and the second one, A is equal to 2. Now, from equation number 1, we know that your B is equal to 4 minus A. So if A is equal to minus 1, we will get B is equal to 5. And if A is equal to 2, you will get B is equal to 2. So here we get two options. The first option is your Q can be minus 1 comma 5. Let's find out direction of AQ. That means we have to find the slope of AQ by taking
difference of y, which is 2 minus 5 upon difference of x, which is minus 1 plus 1, or we can say your slope is infinity. Therefore, we can say the AQ line is vertical line, and in second option your Q having coordinates 2, 2. So let's find out direction of AQ in this case. So your slope must be difference of y coordinate, which will be 2 minus 2 upon difference of x coordinate, which will be minus 1 minus 2. So it will be 0. So we can say in this case your AQ is horizontal line. So here we get our two final answers. AQ is vertical or horizontal line. Ta-da! In this question, we have to find distance of line L from point 1, 2, let's say AB, along the direction L2, 2x minus y equal to 0. Let's say here we have our A point having coordinate 1, 2, and this is your line L1 having equation of line 4x plus 7y plus 5 is equal to 0. And we have to find distance along line L2 having equation 2x minus y equal to 0. So if we say intersecting point of L1 and L2 is Q having coordinate A comma B, then we have to find distance AQ. We just have to find out intersecting point between L1 and L2. So we have to solve equation of L1 and L2. And for that, let's make y subjective from second equation. Your y will be 2x. Now, let's substitute the value of y in your first equation. So we will get 4x plus 7 times 2x plus 5 is equal to 0. Or we can say we will get 18x is equal to minus 5, which will give us x is equal to minus 5 by 18. Now we have to substitute these values of x in equation of y, which is given by 2x, or we can say 2 times minus 5 by 18 will give us minus 5 by 9. So here we get the coordinate of q, which is minus 5 by 18 and minus 5 by 9. And we already have coordinate of a, which is 1, 2. And we just have to find out distance between a and q. Let's find out AQ square, which is nothing but difference of x coordinate the whole square, or we can say 1 plus 5 by 18 the whole square plus difference of y coordinate the whole square will give us 2 plus 5 by 9 the whole square. So we will get 23 by 18 whole square plus 23 by 9 the whole square. So let's take 23 by 9 the whole square common. So we will get 1 by 4 plus 1, or we can say we will get 5 by 4. So your AQ must be 23 root 5 by 18 unit as your final answer. Ta-da! We have to find an equation of line passing through the point of intersection of these two lines. Let's say first one is your L1 and second one is your L2 line. Now, we know that equation of line, let's say L, passing from the intersection of L1 and L2 is given by L1 plus K times L2 is equal to 0. So, let's substitute the equation of line. Your L1 is 4x plus 7y minus 3, and your L2 is 2x minus 3y plus 1
is equal to 0. Now, let's simplify. Collect the terms of x. We will get 4 plus 2k times x plus collect the terms of y. So we will get 7 minus 3k times y. And finally, your constant terms, which is minus 3 plus k is equal to 0. So we get our equation of line. Now we just have to find the value of k. And for that, we have one condition. Our equation of line having equal intercepts on x-axis. And to get intercept on the axis, let's compare this equation of line with standard equation of line, which is ax plus by plus c is equal to 0. So we can say a, which is coefficient of x, is 4 plus 2k. B, which is coefficient of y, is 7 minus 3k. And your constant term is minus 3 plus k. Now, we know that x-intercept is given by minus c by a. So we will get minus 3 plus k upon a, which is 4 plus 2k. And your y-intercept is given by minus c by b. Substitute the value of c, which is minus 3 plus k, and your b is 7 minus 3k. Now, it is given that your x-intercept is equal to y-intercept. So, let's compare your x-intercept with your y-intercept. So, here minus minus become plus, k minus 3 will cancel out, and we will get 4 plus 2k is equal to 7 minus 3k. Or we can say 4 minus 7 will be minus 3, and on right hand side, if we take 2k, we will get minus 5k. Or we can say your k must be 3 by 5. Now let's substitute the value of k in equation number 1. So we will get 4 plus 2 times 3 by 5 x plus 7 minus 3 times 3 by 5 plus minus 3 plus 3 by 5 is equal to 0. So here we'll get 4 plus 6 by 5, or we can say, or we will get 26 by 5 x plus 35 minus 9 by 5 will give us 26 by 5 y. And finally, minus 3 plus 3 by 5 will be minus 12 by 5 is equal to 0. Or we can say we will get 13x plus 13y is equal to 6 is your required equation of line. Ta-da! Here we have one interesting question. A person is standing at the junction of two straight paths represented by equation L1 line and L2 line. Wants to reach a path whose equation is 6x minus 7y plus 8. Let's say this is your L2. In least time, we have to find equation of path that can be followed. So in this question, our person is standing on a junction of two lines, let's say L1 and L2 at point P. He wants to go on a path of equation of L3 line, and he wants to go in least time. That means it should take a shortest path, and shortest path is nothing but perpendicular distance from the point on a line. Or we can say we should go on path PM. That means we have to find equation of PM line. So here line PM is passing from intersection of L1 and L2 line. So we can say the equation of PM is given by L1 plus K times L2 equal to 0. Now let's substitute the equation of line L1 and L2, or if we collect terms of X, we will get 2 times 3K. Then collect the terms of Y, we'll get minus 3 times 4K, and from constant terms we will get 4 minus 5K is equal to 0. So we get our equation of PM line. Now we just have to find the value of K, and to get the value of K, let's use condition in which PM is perpendicular to L3. So we can say the product of slope of PM and slope of L3 must be minus 1. So first of all, let's try to get slope of PM, which is given by minus A by B. Here A is nothing but coefficient of X, which is given as 3K plus 2, and B is nothing but coefficient of Y, which is 4K minus 3. To get slope of L3, let's write down equation of L3, which is given as 6x minus 7y plus 8 is equal to 0. So we can say slope of L3 will be given by minus A by B, or we can say minus coefficient of X, which is 6, upon coefficient of Y, which is minus 7, or we can say 6 by 7. Now, it is given that your PM is perpendicular to L3. So we can say slope of PM into slope of L3 must be minus 1. So let's multiply your slope of PM with slope of M3. Now let's simplify. Here minus minus become plus 1. We have to multiply 6 with 3K plus 2. We will get 18K plus 12. And we have to multiply 7 with 4K minus 3. And it should move on the right side. So we will get 28K minus 21. Now, let's collect the terms of K on the right side. We will get 10K, and 12 plus 21 will be 33. So here we'll get K is equal to 33 by 10. So we get the value of K, and it's time for the third step, in which we are going to substitute the value of K in your equation number 1. So we will get equation of line PM. So here we'll get X into 2 plus 3 times K, which is 33 by 10, plus Y into minus 3 plus 4 times K, and 4 minus 5 times K is equal to 0. So let's simplify. Here we'll get X into 20 plus 99 by 10 will be 119 by 10, plus Y minus 30 plus 132 by 10 will be 102 by 10. And finally, 40 minus 125 by 10 will be minus 125 by 10 is equal to 0. Or we can say we will get 119x plus 102y is equal to 125 as your required equation of line. Ta-da! In this question, we have to prove that the product of length of perpendiculars from point A and B to the line L is given by B square. So we have to find perpendicular distance from point to line. Now, before we go for the equation, let's simplify our equation of line. Let's take an LCM of A and B. So here we'll get X into B cos theta plus Y into A sin theta minus AB is equal to 0. Now let's find out perpendicular distance from point A to the line L. And we know that we have to substitute under root of a square minus b square instead of x. So we will get under root of a square minus b square into b cos theta plus, instead of y, we have to place 0 minus ab upon under root of coefficient of x whole square, or we can say b square cos square theta plus whole square of coefficient of y, which is a square sine square theta. Similarly, we can find out P2, which is perpendicular distance from B to L. So we will get mod. This time we have to substitute minus under root of a square minus b square instead of x. We will get minus under root of a square minus b square into b cos theta plus, instead of y, we have to place 0, so that will be 0. Minus ab will be as it is upon under root of coefficient of x square plus coefficient of y square. So we get our P1 and P2. Now, we have to prove that the product of P1 and P2 is B square. So without wasting time, let's begin from the left hand side, which is P1 into P2. So let's get your P1 and multiply with your P2. Now, as you can see, in denominator we have same quantities within the root. So that will become b square cos square theta plus b square sin square theta. Let's simplify their numerators. From first term, we can take b common. So we'll get mod b into under root of a square minus b square cos theta minus a into, from second term, we can take minus b common. So we will get under root of a square minus b square cos theta plus a. So here mod b and this mod minus b, or we can say mod b, will become b square. Now here we have product of x minus y and x plus y. So it can be rewritten as x square minus y square. So here we'll get whole square of under root of a square minus b square cos theta, which will become a square minus b square cos square theta minus the square of y, which is a. So it will be minus a square upon your denominator will be remain as it is. Now, in further simplification, we can multiply this cos square theta with a square. We'll get a square cos square theta, and cos square theta multiplied with b square will give us minus b square cos square theta, and your minus a square will be as it is. Your denominator still remain as it is. Now, here we have a square cos square theta minus a square, or we can take minus a square common. So we will get 1 minus cos square theta, which can be rewritten as sin square theta minus b square cos square theta, and your denominator will be remain as it is. So if we take minus common from the mod, we will get a square sin square theta plus b square cos square theta upon your denominator will still remain as it is. So a square cos square theta plus a square sin square theta will cancel out. Mod minus 1 will become 1, and you will get b square, which is nothing but p1 into p2. Hence proved. Ta-da! In this question, we have one ray passing from point
A, which is 1, 2, and reflected on x-axis at point A, and reflect back and passing from phi 3 point. So we have to find the coordinates of A. Let's say this is your x-axis, and we have one ray which is passing from 1 comma 2 point and incident point A. Let's say its coordinates will be A comma 0 because it is on x-axis. Now it will be reflected back and passing from point 5 comma 3. Now if we draw a normal from incident point, we can say your incident angle, let's assume as alpha, will be equal to as reflected angle. So this angle will be also alpha. So we can say your this angle must be pi by 2 minus alpha, or let's say this is your theta. Similarly, here we'll get pi by 2 minus alpha, which is same as theta. Your 1, 2 point is assumed as P and phi 3 point is assumed as Q. So we can say the slope of AQ must be difference of y coordinates, which is 3 minus 0 upon difference of x coordinate, which is 5 minus a, and it must be equal to tan of angle with positive x-axis in anti-clockwise direction, which is nothing but theta. Similarly, we can find out slope of PA by taking difference of y coordinate, which is 2 minus 0 upon difference of x coordinate, which will be 1 minus a. And we can also find out tan angle with positive x-axis in anti-clockwise direction. This is your angle theta. So this must be pi minus theta. So let's write down pi minus theta. And we know that tan pi minus theta is nothing but minus tan theta. So if we compare equation number 1 and 2, we will get 2 upon 1 minus a is equal to minus of 3 upon pi minus a. Now let's cross multiply. Pi minus a multiply with 2 will give us 10 minus 2a is equal to 1 minus a multiply with minus 3 will give us minus 3 plus 3a. So here we'll get 13 is equal to 5a, or we can say your a must be 13 by 5. So the coordinate of a must be 13 by 5 comma 0 is your final answer. Ta-da! In this question, we have two lines. Let's say L1 line, which is y is equal to 3x plus 1, and L2 line, which is 2y is equal to x plus 3. And it is equally inclined with line L3, which is y is equal to mx plus 4. And we have to find the value of m. Now here we can say slope of your L1 line is given by 3. Slope of your L2 line, if we take 1 on the right side, we'll get 1 by 2. So this will be 1 by 2. And slope of your third line is given by m, which we have to find. Now, let's assume that theta is angle between line L1 and L3. So we can say your tan theta must be mod m3 minus m1 upon 1 plus m3 into m1. So here we'll get m minus 3 upon 1 plus 3 times m. Let's say this is your equation number 1. Now we can say theta can be angle between line L2 and L3. So we will get tan theta is equal to m3 minus m2 upon 1 plus M3, M2. Or if we substitute the values, we will get M minus 1 by 2 upon 1 plus M into 1 by 2. Or if we take LCM, we will get 2M minus 1 upon 2 plus M. Let's say this is your equation number 2. So if we compare equation number 1 and 2, on left hand side, you will get mod M minus 3 upon 1 plus 3M. And on right hand side, 2M minus 1 upon 2 plus M. Now, if we remove the mod, we will get M minus 3 upon 1 plus 3 times M is equal to plus or minus 2M minus 1 upon 2 plus M. So we have to take two different cases. In case number 1, let's take plus. So you'll get M minus 3 upon 1 plus 3M will be equal to 2M minus 1 upon 2 plus M. Now let's cross multiply. 2 plus M multiply with M minus 3 will give us M square M minus 6 is equal to 1 plus 3M multiply with 2M will give us 6M square minus M minus 1. Minus M will cancel out. We will get 5M square is equal to minus 7, which is not possible. Now let's take second case. 2 plus M multiply with M minus 3. So we will get M square minus M minus 6. And on right hand side, 1 plus 3M multiply with minus of 2M minus 1. So we will get minus 6M square plus M plus 1. So we will get 7M square minus 2M minus 7 is equal to 0. So we get our quadratic equation ax square plus bx plus c equal to 0. So by comparing them, we will get coefficient of x square as a 7, coefficient of x will be minus b, and your constant term will be minus 7. Now first of all, let's find out discriminant, which is b square minus 4ac. Okay, so we will get 4 minus 4 times 7 into minus 7, or we will get 200, which is greater than 0. So we can say we will get real and distinct root of m using minus b plus or minus root delta upon 2 times a. Now let's substitute the value of b, which is minus 2. So we will get 2 plus or minus under root of 200, or we can say 10 root 2 upon 2 times your a, which is 7. So finally we will get m is equal to 1 plus or minus 5 root 2 upon 7 as a final answer. Ta-da! In this question, we have to find image of point 38, let's say A, with respect to line x plus 3y equal to 7. Let's say this is your equation of line L. Assuming that line will be behave as plane mirror. Let's assume here we have our equation of line L, which is given by x plus 3y minus 7 is equal to 0. And here we have our point A, 3, 8, and its image B having coordinates A, B. So we can say your AB is actually perpendicular to line L, and its midpoint M is on line L. So here we get our two required conditions, and we have to find the value of AB. So let's obtain our two equations. Our first condition is line L is perpendicular to line AB. So let's try to get slope of L from its equation of line, which is x plus 3y minus 7 is equal to 0. So we can say slope of L is given by minus a by b, the coefficient of x, which is 1, and coefficient of y, which is 3. Similarly, to get slope of AB, we have to take difference of x coordinate, which will be b minus 8 upon difference of x coordinate, which is a minus 3. Now, it is given that L is perpendicular to AB. So we can say m into MAB must be minus 1. Your m is given by minus 1 by 3. And your slope of AB is given by b minus 8 upon a minus 3. So here minus minus become plus, and we will get b minus 8 is equal to 3a minus 9, or we can say we will get 3a minus b minus 1 is equal to 0. So we get our first equation. Now to obtain second equation, let's use the coordinate of m, which is midpoint of point A 3, 8 and point B, which having coordinate a, b. So we can get coordinate of m by taking summation of x coordinate by 2, or we can say a plus 3 by 2, and summation of y coordinate by 2, or we can say b plus 8 by 2. And we know that m is on line L, and the equation of line L is x plus 3 times y minus 7 equal to 0. So we can say m must be satisfied the equation of L. So let's substitute the x coordinate of m, which is a plus 3 by 2, and y coordinate of m, which is b plus 8 by 2 minus 7 is equal to 0. Now let's simplify. Take the LCM of 2. We will get a plus 3 plus 3b plus 24 minus 14 is equal to 0. Or we will get a plus 3b, 3, 24 minus 14 will give us 13 is equal to 0. So we get our second equation. Now we have to solve equation number 1 and 2. So let's multiply equation number 1 by 3. So we will get 9a minus 3b minus 3 is equal to 0, and a plus 3b plus 13 is equal to 0. We have to add both equation. So 9a plus a will be 10a, 3b will cancel out, and we'll get 13 minus 3, or we can say 10 is equal to 0. So we will get a is equal to minus 1. Now let's substitute the value of a in equation number 2, which is a plus 3b plus 13 is equal to 0, or we will get b is equal to minus 4. So we can say the image of point A, which is B, having coordinate minus 1 and minus 4, is a required point. Ta-da!